This is a review for the first part of the Chapter 1 test. This part will be without a calculator, and the things that you're going to end up having to do for it would be to evaluate some functions, determine whether they're even, odd, or neither, dealing with the composition of functions, parent functions and what happens to the original function and how it's shifted, stating the domain and range of some functions, and then figuring out the equations of lines that are parallel and perpendicular to a certain line. So here are some examples of the things that you will see on tomorrow's part of the test. First, evaluating some functions. So all you need to do is substitute here in this one f of a -7. We're going to go into the f function and substitute a -7 in. So it's 2 times a -7 plus 5. And so that's a -14 plus 5, which is a -9. Our second one, g plus f of 2. So here we want to figure out what is g of 2 and then what is f of 2. So first off, g of 2 is 2 squared minus 2, which is 2, because 4 minus 2 is 2. And then f of 2 would be 2 times 2 plus 5, which is going to be 9. So then g plus f of 2, we have to take these two answers and add them together to get our answer to what is actually being asked, and that's g plus f. Now had this been a subtraction sign instead, then you'd have taken 2 minus 9. Multiplication sign, done the same thing. Division sign, done the same thing. Our next example here is h composition f of 8. There could be parentheses here. There doesn't necessarily have to be. And remember that this could be written as this as well. It's the same thing. What you need to end up doing is first figure out what is f of 8. So it's 2 times 8 plus 5, which is going to be 21. And then we need to figure out what is h of 21, because we take the answer we got for the first part and substitute it into the other. So we have 21 minus 2 plus 1, which is going to be 20. Finally, our last example here is g to the -1 power of x, which you really don't read it that way. What that is saying is find the inverse of g. So to find the inverse of g, this function here, y equals x squared minus 2. Now you can either switch the x and the y, or you can just solve for x. Either way, however you want to do that, it's the same thing. We just need to get now that variable by itself. So you're going to add 2 to get y plus 2 equals x squared, and then take the square root. And so then x equals plus and minus the square root of y plus 2. So now when you write the answer, g, the inverse of g, because we use this variable, then when you write this part, we also have to have the same variable in it. So it becomes plus and minus the square root of x plus 2. And like I said, if you wanted to, you could switch the x and the y and now solve for y, and you would still get the same thing. And now you wouldn't have to worry about switching the variable of the inverse of g. And that's the first types of problems you will see on tomorrow's test. So now moving on to the parent functions. For this particular function, the parent function is just plain x. The domain for this particular function is from a -infinity to infinity. All reals, if you want to write that instead. The range would be the same thing, -infinity to infinity. All reals. Remember, domain is what you can substitute in for x, and range is what answers you would get when substituting those things in. Then figuring out if it's even, odd, or neither. This one in particular would be neither, because if you substitute a -x into this, you will get -2x plus 5. And this is not the same as that, so it's not even. And this is not exactly the opposite of it either, so then it's neither. This part is opposite, but that's the same. So because it's not the same and it's not completely opposite, it is neither. And finally then our shifting. The plus 5, it's not with the x, so that is going to move it up 5. And the 2 is going to stretch it vertically by 2. Because again, it's not with the x, so then it's the same as what's happening. If it was with the x, it would be the opposite of what's happening. Our second function here, the parent is x squared. Domain is still going to be a negative infinity to infinity, or all reals if you want to say that. The range now is going to be everything from a negative 2 to infinity. And it includes a negative 2 because if you substitute a 0 into this, you get a negative 2. A 1 gets you a negative 1, and a negative 1 gets you a negative 1. And if you substitute a 0 or a 2 in, you would get 2. Negative 2, you also get 2. So it's everything greater than a negative 2. And equal to a negative 2. And so you could also say all greater than or equal to a negative 2. Then determining if it's even, odd, or neither. Again, if you substitute a negative x in, if you square that, you are going to get x squared minus 2. And now this is exactly the same as that. So therefore, it is even. And our stretching and shifting, it would be shifted down 2 because of the minus 2. Our last example here is absolute value of x minus 2 plus 1. The parent function is the absolute value of x. The domain is a negative infinity to infinity. The range is going to be everything greater than or equal to positive 1. So 1 to infinity. Even, odd, or neither. It is going to be neither, because when you put a negative x into this, you get this, plus 1. Not exactly the opposite, not exactly the same. And our shifting and stretching, in this particular case, it would be up 1 for the plus 1 and right 2. Now, one thing you might be questioning is how come, or when would the domain not be all reals? Well, that would be as if when you have a fractional thing, because you can never divide by 0. So if you had 1 over x plus 5, then your domain would be all except for a negative 5, because a negative 5 makes that 0. The other thing where you can't have a square root, it's got to be 0 or above, so a negative 1 makes it 0, so you'd say everything greater than or equal to a negative 1. Those are a couple of examples of things where the domain is not all reals. All right, moving on to this next one, you may get a graph and have to look at it and figure out what the domain is. Domain, remember, are the x values, so we're starting at this point and moving our way across the x-axis. So we would say everything greater than or equal to a negative 4. And if you wanted to write it as an interval, it would be that. Our range are our y values, and this looks like it's the lowest y value, and then it continues up forever. So we would say all greater than or equal to a negative 2. Now then, here's another example of a function, and this one, the parent is going to be 1 over x. 1 over x looks like this. So therefore, it is shifted down 5 and left 2, because this is like in a grouping symbols, and even though they're not there, but because it's underneath, it's a fraction, it's all considered one thing, so it is impacting the x value. And so this whole thing is going to go down 5 and left 2, and so it's going to look like that as far as how it's graphed. The domain is going to be all except for negative 2, because because if you substitute a negative 2 into that, you'd get 0, and you can never divide by 0. The range in this case is going to be all except for negative 5. because that's this right here. And if you, no matter what you put into for x, what you substitute in for x, this is still going to be something greater than 0 or less than 0. It's never going to get to 0, so we cannot have 0 minus 5 to get a negative 5. Then for even, odd, or neither, if you substitute a negative x in, you'd get 1 over a negative x plus 2 minus 5, and that is neither. And in looking at the graph of it, it would have to be folded right there in order for it to be even, and it would have to be reflected over that point for it to be odd. And this particular function that is here, it has odd characteristics, but it doesn't get folded over or reflected over that point. It gets reflected over this point, so it's not odd. Now moving on. Here we're going to try to find the line that goes through these two coordinates. So first we would want to find the slope, which is 20 minus 6 over a negative 4 minus 2. And so you would get 14 over a negative 6, which simplifies to a negative 7/3. Then, finding the y-intercept, you can choose either one of the 2 points. So 6 equals negative 7/3 times 2 plus b. That is going to be a negative, let's make that a 3 because that's what it's supposed to be. This is going to be a negative 14/3 plus b equals 6. Add 14/3 to both sides. And 14/3 is the same as 4 2/3, so we are going to get 10 2/3 for our answer. And so the equation is going to be y equals a negative 7/3 x plus 10 2/3. And if you want to leave this as 32/3, you can. Either way, it is fine. Finally, the last types of examples for this particular part of the test would be to write parallel and perpendicular lines to an equation. Here is our equation of our line, which is one we just got done figuring out. Now we want to be parallel to 910, or through 910. So if we're going to be parallel, the slope has to be the same. So we would have 10 equals a negative 7/3 times 9 plus b. Taking a negative 7/3 times 9, you would get negative 21 plus b equals 10. Add 21 to both sides, and b is going to equal 31. And so now we have y equals a negative 7/3 x plus 31. In our next example, we want to go with a perpendicular line to that one. And remember, with perpendicular lines, the slope has to be the opposite reciprocal, so a positive 3/7. And so if we were going to go through the point negative 7, 5, we would have 5 equals 3/7 times a negative 7 plus b. And then distributing negative, or 3/7 times negative 7, we would have 5 equals a negative 3 plus b. Adding 3, b is going to equal 8. And so our equation is y equals 3/7 x plus 8. And that concludes everything that will be on the first part of the test, which is tomorrow. I will have another review video for the second part of the test posted after tomorrow's test.